What's up, everybody? Today we're going to be talking about Leetcode problem 322, coin change. So we'll start briefly with the problem description. If you want to skip the problem description, it will be in the description below. So we're given some set of denomination of coins. In this example, we are given a 1-cent coin, a 2-cent coin, and a 5-cent coin, and a total amount of change we need to make. So in this case, it's 11. Write a function, or write an algorithm to compute the fewest number of coins that you need to make up that amount. And if it can't be done, return -1. So let's go into the problem. The first thing I want to start out with this problem is actually sort of analyzing what our current denomination is in the United States and going over why this problem is a little bit easier. So how we make change, right, is we just take the largest possible coin we can at any given step. For example, if we need to make 66 cents and change, that would be 25 plus 25, and then we can't take another 25. We can take a 10, so we'll take a 10, and then we can't take any of these three, and we take our last penny, and that's 66. Sorry, it's not 66. That's 61. So we would take a nickel and then a penny, right? So we would just go down the list and we would be choosing the largest possible coin we can at any given iteration. This does not work in the general case, given any coin denomination. Let's imagine this set of coins, and let's say t equals 20. The best answer is clearly 10 plus 10 to 10 coins, 10-cent coins. But the greedy algorithm approach, you would pick 17 and then 3 1-cent coins, and that would give you 4 coins. So the greedy algorithm approach is not going to work. So let's think about this problem in a different way. I want you to imagine that I'm an oracle, okay? I can tell you the answer to any sort of target value except for the value you want to know. For example, if I told you, tell me the number of coins needed to make, let's say, C of 1,000, and let's say our coin set was 3, 4, 5, you can ask me the question C from 0 to 999, or, well, and you can ask me, any of these questions. You can ask me an infinite number of questions, okay? Infinity. You can ask me all these questions if you wanted to. You could ask me infinite number if you want. Could you determine the answer to C1000 given the questions you can ask here? I would argue that you can. And maybe let's look a little bit into why that is. So what's the only way we can get to 1000? Well, we're at some number. What's the only way we can get to any number? Well, I give you a 3-cent coin, or a 4-cent coin, or a 5-cent coin, right? There's no other way, given a coin with these denominations, that you can get to a number. It has to be from 3, 4, or 5. So if you ask me the question, C of 997, question mark, C of 996, question mark, and C of 995, question mark. Could you tell me the answer then, right? Well, let's say this is 3, and this is 1,000, and this is 2,000. If I'm at 997, you could just give me a 3-cent coin. Boom, you're done with 4 coins. If you're at 996, you could give me a 4-cent coin. Boom, you're done in 1,001 coins. And if you're at 995 or 995, you could give me back another coin, a 5-cent coin, and it'll be at 2001. And clearly this solution's best. So for C of 1000, we only needed to know the possible ways we could have got there given our coin set. And that's going to be the algorithm, basically. If we have, we're gonna store. So this is dynamic programming. This is a very classic dynamic programming. We're gonna store some array, and we're gonna initialize 0 cents to be 0 coins, and then we will go through this array. Maybe we initialize it with all infinities or something like that, but we'll go through this array, and we'll be filling this out with numbers. So let's say, you know, this is x1. This is x2. We don't know what it is. It could be one coin, 2 coin, 3 coin. And when we get to target, right, let's say our denominations are 2 and 3, we're just going to look at, this is t minus 1, t minus 2, and t minus 3. We're going to just look at t minus 2 and t minus 3. Tell me what the answers are here. And then I'll be able to tell you what the best solution for t is. And boom, we're done. And you can kind of see that as you're going along, you're filling out every single position, so you know you've already computed t minus 2 and t minus 3. This is very similar to the stair climbing problem, and this is very sort of a general case of coin change. So the code, it will be in the comments below, or in the description of the video below, and hopefully this was helpful. Hope to see you in the next video.